Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Hakimi bin Ahmad Mirza. Today I'm going to present my final year project. The title of my final year project is Tribological Properties of Aluminium Porous Material by using pin on this test. My supervisor is Dr. Nid Roslina Nid Rosli. First, the project summary. In this work, the aim is to investigate the tribological properties of aluminium porous materials. Next, pin on this tribometer was used to investigate the friction and wear rate of the porous aluminum disc. And lastly, the tribological behaviors of the aluminum samples was recorded as the result. Introduction. Tribology. What is tribology? Tribology involves the study and applications of concepts of friction, lubrication and also wear. Next, tribology have a major impact in modern applications such as biomedical, industrial machinery and also nanotechnology. Lastly, tribology involved in the research on the science and engineering or relatively moving surfaces. Next, porous materials. Porous materials is a types of materials that has a low density, broad surfaces and a range of different physical, mechanical, thermal, electrical and acoustic characteristics. Next, porous materials are widely used in many applications such as surgical implants, impact energy absorbers, thermal insulators, porous metal bearings, filters and also heat exchangers. Pin on this test. In this study, there are two types of discs were used, which is the non-porous disc and also the porous disc. The material for both the disc is aluminium. Next, the diameter of the disc is set to be 74 mm and the thickness is set to be 5 mm, while for the pin, the material is mild steel with the diameter of 8 mm and the length is 30 mm. A total of 3 tests using 3 samples, which is sample 1, sample 2 and sample 2 number 2 has been done. Sample 1 is solid aluminium disc, while sample 2 and sample 2 number 2 is porous aluminium disc. The speed of 200 rpm and 300 rpm, load of 5 Newton and 10 Newton and 10 minutes test time has been set for the test. For the porous disc, and engine oil was added as a lubricant. Next, the problem statement. The investigation on porous materials can be a crucial step toward improving its tribological characteristics. However, there is less study that focus on the tribology of aluminium porous materials. Hence, this study will answer the following research question, which is, what is the tribological properties of aluminum porous materials? Next is the objective. There are 3 objectives in this study, which is the first one, to differentiate the tribological properties between solid and also porous disc. Next, to investigate on how the porosity of the disc can affect the wear rate and coefficient of friction. And lastly, to investigate how the load and speed applied during the test affect the size of pores of the porous disc. Next is the methodology. This is the flowchart of the methodology. The first one is preparing samples for pin on this test. 3 samples of this were prepared before running the pin on this test. There are 4 processes involved in preparing the sample, which is milling, cutting, grinding and also polishing. Number 2, porosity of samples. The porosity of both solid and porous samples was observed by using the X-ray digital radiography. Below is the equation used to estimate the porosity percentage of the sample. Number 3, microstructure of the samples. The microstructure of both porous and non-porous discs before and after the tribological test was captured by using stereo zoom microscope and optical microscope. Number 4, weighing the samples. The weight for the disc and pin were taken using analytical balance to estimate the porosity percentage. In addition, samples were also weighted before and after the pin on this test. This is to make sure the weight value were used to calculate the wear rate of all the samples. And lastly, run the pin on this test. The tribological test of all samples were investigated using pin on this tribometer. The counterpart used was mild steel pin with diameter of 8 mm and 30 mm length. The tests were carried out in a room temperature at load of 5 Newton and also 10 Newton. The test time was set to 10 minutes. The picture below show the pin on this tribometer and also the parameters for tribological test. Next, results and discussion. The first one, porosity of aluminum samples. The porosity of samples was investigated using the X-ray digital radiography and optical microscope. The picture below shows the X-ray images of 74 mm diameter of sample 1 and sample 2. Sample 1 represent the solid aluminum while sample 2 represent the porous aluminum. As can be seen in picture B, sample 2 is highly microporous. The porous areas are indicated by the black areas in the image. The weight of samples, calculated density and porosity percentage are summarized in the table below. As we can see, the porosity percentage of sample 2 is higher compared to sample 1, and the density of sample 1 is higher compared to sample 2. The second one is tribological behaviors of aluminum samples. The friction and wear of aluminum samples were measured using pin-on-disc tribometer. The test conditions for all samples were tabulated in the table below. Sample 2 was first set to run with load of 10 Newton, duration of 10 minutes and speed of 300 rpm. However, the wear seemed to be very severe that had caused vibration of the tester. Due to that reason, test was stopped at 5th minute of test. Test was repeated in lower load of 5 Newton at lower rotation speed of 200 rpm, which will be noted as sample 2 in this work. The friction coefficient of all samples were presented in figure below. As we can see, sample 1 has the highest COF due to non-lubricated test condition. Test COF was recorded between 0.8 and 1.0. High noise from sample 2 may come from the vibration that was observed during test. The COF of sample 2 number 2 that was conducted at low load was constant at 0.2. Next, the weight of sample before and after the tribo test was recorded and tabulated in table below. The weight of sample 1 after the tribo test was reduced, which indicate the loss of materials in the sample or wear. Aluminum porous samples of sample 2 and sample 2 number 2 recorded increase of weight after the tribo test. There may be a deposition of additive from the lubricant or debris inside the porous. The microstructures of the samples before and after test were captured using optical microscope and stereozoom microscope. Picture below shows the microstructures of sample 1 before and after the test. The wear track and grooves in sample 1 can be clearly seen in the micrograph in picture B. The microstructures of sample 2 before and after the tribo test are shown in picture below. Severe wear can be seen along the wear track marked in the red dotted line area in picture B. The average size of pore was measured to be 197.3 micrometer to 259 micrometer before the test. After the test, the average size of pore reduced to 99.59 micrometer to 255 micrometer. The microstructures of sample 2 number 2 before and after tribo test are shown in picture below. As for sample 2 number 2, wear track cannot be clearly seen in the micrograph, which might be due to low load applied during the test. The average size of pore for sample 2 number 2 was measured to be 215.3 micrometer to 265.7 micrometer before the test was done. After the test has been done, the average size of pore reduced to 106.35 micrometer to 208.4 micrometer. Lastly, the conclusion. As a conclusion, we can say that the lubrication affects the coefficient of friction of the samples. The coefficient of friction of sample 1 is higher compared to sample 2 and sample 2 number 2 due to the test was run without lubrication. Next, the weight for sample 1 was reduced after the test, which indicate the wear. For sample 2 and sample 2 number 2, the weight increased because there may be deposition of additives from the lubricant or debris inside the porous. And lastly, the size of pore for sample 2 and sample 2 number 2 reduced after the test has been done. This concludes that the load and speed applied can affect the porous structure and also the porous size. That's all from me. Thank you. Assalamualaikum.